kids, and welcome to another video, yet another one on algebraic equations. I think where students really like this chapter a little bit more because you get one answer for x and it's simplified and it's easy, and if you get it, it's right, and if you don't get it, it's wrong, and then you go see where you went wrong. So it's a little bit different than the algebraic expressions where you sometimes end up with one big haha answer and you just hope it's right, and one little part you might get wrong and then you don't know how you got that wrong. So anyway, I think this is a section that you guys really prefer over algebraic expressions. So let's get right into this. Okay, so I've typed up all the types of questions that you can get. So I'm just going to quickly scroll through it. So you get the variables on one side of the equation where there's only one variable on each side. Then you also get variables on both sides of the equation where it becomes a little bit longer. Then you also get using distribution when solving equations, and solving equations using the laws of exponents. So just things that we need to note. And then lastly, solving equations with word sums. And I actually want to show you that it's not so hard. I remember, the dogs are really barking at my house. Sorry for that. I remember at school, I hated word sums. I never liked it. I couldn't understand it. But if you actually break it down, it's actually not so bad. Okay, so I'm going to show you with the viewpoint of understanding that you also don't like it. Okay, all right, so let's start. Let's see if I've got the right pen. Okay, so x minus 3 is equal to 7. And then the teacher that I teach with, that teaches matrics as well, came and told me that she had a class today that they didn't understand that if you are we teach you to throw it over and then the sign changes and you add 3. And when she asked them why they do it, they couldn't really say, which I found a bit strange, but I'm going to show you just why that is, because we want to get x alone. So to get x alone, we need to get rid of that negative 3. All right, so what is the inverse of negative 3? How do we neutralize negative 3? How do we make it 0? By saying, all right, the opposite of minus is a plus 3. But what you do on the one side, you must do on the other side. So that will give you x alone, and minus 3 plus 3 becomes 0. So that basically falls away. And 7 plus 3 is 10. All right, now to make it a little bit easier, I just want to show you there, that's 10. What we normally then afterwards, because when we've got two variables on each side, it becomes a little bit harder to do this inverse. So x minus 3 is 7. So what we teach the students is, I always say, you pick up the negative 3 and you throw it over to the other side, and then it becomes a positive 3. So when he goes over the equal sign, he has a sign change. Okay, and the negative 3 becomes a positive 3. But that is, in actual fact, comes from this theory of why we do it. Okay, and then you also get, x is equal to 10. Okay, so which way you do it, it's up to you. But just please remember that why we say, I always talk about you pick it up and you throw it over, but you're actually doing the inverse of that operation there of plus. If you look at this sum, let me just change my color to plus 5. Opposite of plus 5 is minus 5. So plus 5 minus 5 falls away, but what you do on the one side, you have to do on the other side. So you're left with x plus 0, which in actual fact is just x, equals to 7 minus 5, which is 2. And then I just want to quickly show you, I don't really ask the students to test it for a mark. I just tell them to do it on the side in pencil just to see whether your answer is right. So if you're telling me x is 2, that means that the left-hand side should equal to the right-hand side. Okay, so in actual fact, all you're going to do is you replace where the x is a 2 and you see if it balances out. Is 2 plus 5 equal to 7? Yes, it is. So some people write left-hand side is equal to 7, right-hand side is equal to 7. So yes, it balances out. But in actual fact, what I want you to do is just to go and replace it, even in your mind's eye, if you can later on, and see whether you got it right. Okay, over here. So I always ask, what is happening to x? X is standing right next to, there's not a 2 plus x is 14. If you had to do this way, you had to say 14, and then the positive 2 will come over, becomes a 14 minus 2, and you get x is 12. When in here, if we look at the difference between this one and the right-hand side one, this one, the 2 is multiplying with the x. Okay, so what is the opposite of multiplying? Is dividing. So if you go and divide here with 2, that 2 and 2 will cancel out, and you will be left with x. But what you do on the one side, you need to do on the other side. So x is equal to 7. So if you're going to go test your original, 2x is equal to 14. 2 times 7 does give you 14. So your left-hand side is equal to your right-hand side. Then number D, what is happening to x? So if I write it down, x is being divided with 3. What is the opposite of divide by 3? So x divided by 3, it's times with 3. And see, if you do that, you can cross cancel like that, and you'll be left with x. So you don't have to show it. All you can do is you can say like that, multiplied by 3. But what you do on the one side, you have to do on the other side. So then you'll be just left with x is equal to 12. Let's go test ourselves. 12 divided by 3, does it give me 4? Yes, it does. So your left hand is equal to your right hand side. Okay, over here, it becomes a little bit harder. There's a 4, but what is in front of it? A positive 4. So we're going to subtract 4 on this side and subtract 4 on that side. The other way you could have seen it is you pick up this plus 4 and you throw him over to the other side, and he becomes a minus 4. So in actual fact, he disappears here. But what you actually did is you subtracted 4 on each side. So what is left? A positive 2x. So you don't have to write that positive. 12 minus 4 gives you 8. And now you say, what is happening to x? It is being multiplied with 2. So you're going to do the inverse and divide by 2 on each side. So x is 4. All right, I just want to show you here, sorry. This 2 and x, they are married. They're a little bit attached. Shame. Leave them alone. They are one term. You need to throw over all the other terms that is loose to 2x. Okay, that is not attached to 2x. And that was this positive 4 over here. So we first get rid of the positive 4, and then when you've got 2x is equal to 8, one term is equal to one term, then you divide away with that 2. Same here. The 3x is married. Leave them alone for a little while longer. And then I've got the negative 17, and this loose term, if I throw it over, it will become a plus 5. So let me just write it there. Thus 3x is equal to minus 17 plus 5 is negative 12. Am I right? Yes. Okay, and now you say, what is attached to the x? A 3. So I divide away with a 3, and I'm left with a negative divided by positive is a negative. 12 divided by 3 is 4. Please note that can you see I am not putting equal signs here on that side. That is totally wrong. You cannot have something equal to something equal to something. So we have to keep, some teachers are very specific. They say they even let you draw a little line with your equal sides like that. And then you have to keep the left and the right, the equal signs underneath each other. Okay, but just to show you, please, if you are OCD, like you obsessive compulsive disorder, you want to write something in front, then you can put a little thus sign like that, which is 3 dots, which means from that equation, thus 3x is equal to thus, thus. Okay. All right. So the 4x is attached to each other. We're going to leave them alone for a little while longer. I'm going to take this positive 7 and take it to the other side of the equal sign, which makes it 5 minus 7 is equal to 4x. 5 minus 7 is negative 2 is equal to 4x. And what is in front of the x that we don't want there? Very important, a 4. So we divide away with 4 on each side. Thus, negative 2 divided by 4 is negative a half is equal to x. Now, people, you are more than welcome just to go and swap those two around, okay, by writing the x first. I'm not going to go into nitty-gritty as to why, because it just confuses my kids as well when I try and explain to them. So you can just swap it around. Okay, now into the little bit of a harder one. So, sorry, I just want to stop there and quickly just explain. This is now separate. These aren't answers that I've gotten. If you've got somehow negative x is equal to 4, you're going to say, I'm going to divide by negative on each side. So if you divide here with a negative and there with a negative, sorry, the negative divided by negative is a positive x, and the positive divided by negative is a negative 4. So what I tell my students is, when you've got one term on each side, and the one is a negative x, remember we want to solve for x, not negative x, then you just pass over that negative to the other side. If you get negative x is equal to negative 4, those two can just cancel out and you get x is 4. Okay, the two negatives cancel each other out. But in actual fact, what you are doing, is you are dividing with a negative here and dividing with a negative there. Negative divided by negative is a positive, and a positive divided by negative is negative divided by negative is also a positive. So that's why. So very important. Just jot that down somewhere in your book. I just want to delete that as well. Sorry. There we go. Okay. So if you've got two negatives, the two negatives you can just in your mind's eye think it cancels out and x is 4. And if you've got negative x is equal to 4, then you just pass over that negative, because we never ever want to find negative x, we want to find just x. Okay, so sorry, I didn't write it so neatly there, but just remember if you ever end up with answers like that. Okay, then let's get to the harder ones. A half x minus 3 is equal to 4. So a half x is equal to, the negative 3 goes over and becomes a positive 3. 4 plus 3 is 7. Then you're going to divide with whatever's in front of the x, away with that. And what you do on the one side, you have to do on the other side. So this will cancel out, and x is equal to 14. All right, so you can put that in your calculator or you can times and tip. It's up to you. All right, so now 7 minus 2x over 3. Now people, please look carefully. This is attached to each other. They are together at the top of the fraction, together. So you cannot break them up yet. We want to get rid of this divided by 3. So what are we going to do? We're going to times by 3 on each side. Because what is the opposite of divide by 3? Times by 3. So 7 minus 2x is equal to negative 3. The negative 2 stays here. And the negative 3 minus 7, because if there's nothing there, there's a plus. Thus, negative 2x is equal to negative 10. Now whatever's in front of the x, I divide away with that. That will cancel out. But what I do on the one side, I have to do on the other side. Thus, x is a negative divided by a negative is a positive, and 10 divided by 2 is 5. Okay, what if there's variables on both sides of the equation? Then we want to bring all the x's together on the one side and all the normal whole numbers to the other side, or all the other integers actually to the other side. So I normally take the x's to the bigger side, where the x is bigger. It doesn't matter though, but just so that I'd never end up with a negative x, but it's up to you. Okay, so I'm going to bring this positive 4 over. The 5x stayed here. It didn't change direction. So I'm going to make a little stipple line there. The plus 4x becomes a minus 4x. On the equal sign, the 6 came down. He stayed a positive 6. I didn't change his direction. And the negative 2 comes over and becomes a positive 2. And now you can simplify. 5x minus 4x is just x. And 6 plus 2 is 8. Now, you can go and test it as well. Especially, I said to the students, if you end early or if you finished early with your test, go and test all your answers and you can sort of mark it yourself. So whenever you see an x, you replace it with an 8 times 8. And we want to see actually if our left side is equal to our right side. So we're not going to put an equal sign there because we don't know yet. 5 times 8 is 40, minus 2 is 38. And 6 plus 40, 8 plus 8 is 16, 32. 6 plus 32 is 38. So can you see that my left hand is equal to my right hand? So my answer is correct. Okay, over here, I'm going to take the 3x over to that side. I'm going to take the positive 2 over to the other side. So what is left? If I do a little dotted line, keep my equal sign over here. 3x, so the negative 7 stayed here on this side, and the positive 2 came over, it became a minus 2. Can you see it doesn't matter where you go put it? If you wanted to put the minus 2 first, it will still give you exactly the same answer. And then over here, 5x stayed here, and the positive 3x came over and it became a minus 3x. So minus 2 minus another 7 is minus 9, and 5x minus 3x is 2x. And then I say divide by 2, divide by 2. Thus, negative 4.5 is equal to x. I just want to quickly double check myself. All right, and that is correct. Okay, again, you can just swap it around to say x is negative 4.5. The signs exactly stay like it is. It just swaps around. Okay. Over here, now I've got a quarter x, which I don't like at all. And did you know that you can go and times by 4 all throughout? So why do I say times by 4? Because you've got an equation. You can't do this with an expression. You want to get rid of this quarter x. And the opposite of a quarter, if you had to flip this around, will give you 4 over 1, which is 4. So if you times with 4 all throughout, 4 times x is 4x minus 36. A quarter times 4 gives you just an x, which we wanted to get rid of that fraction. That's why we did it. Plus 4 times 3 is 12. So if you want to, this is a bit of a harder one, but if there's a fraction, that you want to get rid of, you just times it with the inverse of it or the opposite of it. You just flip it around, times 4 over 1. So if you had a half, you would times all throughout with a 2 or a 2 over 1. If you have a third, you would times with a 3. If you had 1 over 8, you would times with 8. Okay, because that will always give you 1 times 8 is 8. 8 times 1 is 8, which will always give you 1 then. Okay, so just please remember that if you ever come across one like that, and then you can easily go and and simplify for x, or find x. 4x minus x is 3x, and 1 plus 36 is 37. Then you divide by 3 on each side because x is being multiplied with 3. That will give you x is equal to 12 and a third. And how did I get that? I just put it into my calculator. Okay, so I just want to make sure that I've done it all correctly. Okay, now luckily I checked. Sorry about that. If you times the 3 with 4, it gives you 12. I don't know if I erased it by accident. Sorry. Don't know what happened there. So 4x minus x gives you 3x. And 12 plus 36 gives you 12 plus 36 gives you 48. And then you divide by 3 on each side, which will luckily give you a better answer, which is 16. Sorry about that. Okay, so it was a 12 there at the end because I times with 4 all throughout. The x times 4 is 4x. The negative 9 times 4 is negative 36. A quarter x times 4 gives you x, and 3 times 4 gives you 12. Sorry about that. Okay. Then if we look at number D, what is happening? You are dividing by 3, so I'm going to times by 3 on each side to get rid of this divide by 3. So then I'll be left with 5 minus 2x is equal to negative 12x. Then you want to bring all the x's to one side. So 5 is equal to negative 12x plus 2x, which gives you negative 10x. What's in front of the x that I don't want there? A negative 10. So you divide it with negative 10. Thus, negative a half is equal to x. And you are more than welcome to swap it around. All right, and then the distribution that you've only been taught this year. So remember, distribution is when there's something in front of the something in front of the brackets. And how do you get rid of the brackets? By multiplying with whatever's in front into those brackets. So 7 times x, 7x, plus 7 times 2 is 14, is equal to 6 times x, which is 6x, plus 6 times 1 is 6. Thus, I'm going to take the 6x over. It becomes a minus 6x. The 6 was here on this side. If I take the positive 14 over, it becomes a minus 14. Thus, 7x minus 6x is just 1x. And 6 minus 14 is negative 8. Am I right? I'm doubting myself the whole time. That is indeed correct. Okay, over here again, I'm going to distribute the 5 into the bracket, which gives me 5x minus 5 is equal to 4x minus 8. You want to bring all the x's to one side, all the x's, and on the other side, all the normal numbers. The negative 5, if it goes over, it becomes a positive 5. And did you see here the 5x stayed? And the 4x, a positive 4x went over and became a negative 4x. Thus, x is equal to negative 8 plus 3. Negative 8 plus 5 gives you negative 3. Okay, remember that you can have any other variable. Doesn't have to be an x. So 2 times 2 is 4 minus 2p is equal to 3p plus 3 times 3 is 9. Bring all your p values together. 4 minus 9 and the 3p on this side plus 2p. Hope I'm not going too fast. So 4 minus 9 gives you negative 5. And 3 plus 2p is 5p. What is in front of the p that I don't want there? A 5. Thus, p is equal to negative 1. Okay, so if you could see, I got negative 1 is equal to p, but then I just swap them around, and you can do that. All right, number D, and then we're going to get into the exponents. Multiplying a half into a bracket, people, don't be scared of fractions, although I know you are. So a half times 2, a half times 2 gives you 2 over 2, which is 1. And a half times 4 is 2x. And 7 times x is 7x. Minus 7, and at the end there was that minus 2 as well. And then something that I always tell the students, even in grade 9, when it gets a little bit more intricate, is I always say first simplify both sides. Okay, so the left hand side cannot be simplified more, but the right hand side can. So 7x minus 7 minus another 2 is minus 9. And then it just helps you not to make a mistake with throwing so many things over to the one side. Okay, so 1, I'm going to bring this negative 9 over that side. So 1 plus 9 is equal to 7x minus 2x, which gives you 10. And 7x minus 2x is 5x. What's in front of the x that you don't want there? A 5. So 2 is equal to x, thus x is equal to 2. I just always like to write x first. So again, you can go test your answer over here. Let's go test it. A half times 2 plus 4 times 2, which gives you 8. That's your left-hand side. And your right-hand side is 7 times 2 minus 1 is 1 minus 2. So that gives you 5. 2 plus 8 is 10. A half of 10 is 5. So can you see that I've tested it? Okay, solving equations using the laws of exponent. Okay, so 2 to the power x is equal to 4. Now, do you know that every number is made up out of a prime base? So 4, if you go and put it into, you can do the ladder method, or if I remember correctly now, but in your calculator, there's an option of asking your calculator what the product of its prime is of 4. And how you do it is you say 4, you put in 4, you press equal, and then you say shift and the fact button. Now the fact button is a dot, comma, comma, comma button. And if you press that, it will tell you that 4 is made up out of 2 to the power of 2. So you want to bring down the numbers that are not prime numbers. You want to break it down into a product of its primes. So 4 is made up out of 2 to the power of 2. And once you do that, you can drop it like it's hot. I always say that. So once you're 2, you've got one term on each side, and they are the same. Then you can drop it like it's hot, and the exponents equal to each other. Okay, let's do another one and see if you can. It is quite hard, these ones. 3, if there's nothing, there's a 3 to the power 1 times 3 to the power x. And 9, if you put in 9, equals shift fact. Or you do the ladder method. I know some people say 9 divided by 3 is 3. 3 divided by 3 is 1. And then I'm done. So 9 is made up out of 3 squared. Okay. So with your exponent rules, remember, if you've got the same base and they are multiplying, you keep the same base and you add the exponents. Okay. So this is a bit hard, but maybe some of you can do it. Then once you've got the prime numbers the same, the base the same, you drop it like it's hot. And then 1 plus x is equal to 2. And then you can find x is equal to 2 minus 1, which is 1. Does that make sense if I go and replace it into the original? 3 times 3 to the power of 1 should give you 9. Yes, 3 times 3 does give me 9. Okay, 81. If you had to break it down in the product of its primes, if you had to use the ladder method, 81 divided by 3 gives you 27. 27 divided by 3 gives you 9. 9 divided by 3 gives you 3. 3 divided by 3 gives you 1. So 81, let me first start here. 81 is going to be 3 to the power 1, 2, 3, 4. Okay, so if your teachers don't allow you to use calculators for that, then you can still work it out with the ladder method. And then a power raised to a you just multiply. It's a bit of it, yeah. So 2 times, you just distribute. 2 times x is 2x minus 2. Then, is your basis the same? Yes, you drop it like it's hot. And 2x minus 2 is equal to 4. And you just solve for x from there. Divide by 2 on each side. Again, you can go test yourself. 3 to the power 2. X is 3. I replace it in there. 3 minus 1. It should give me 81. 3 minus 1 is 2. 2 times 2 is 3 to the power 4. And yes, it does give me 81. Okay, over here, I keep the same base and I add my exponents. And if I've got equal to 3, then remember it's to the power 1 over there. Okay, I've got the same base. So here I kept the same base and I added my exponents. Okay, and then 3, just remember there's nothing, it's to the power 1. Drop it like it's hot. Thus 2x plus x is 3x is equal to 1. Then what is in front of the x that we don't want there? A 3. They cancel out. So x is a third. All right. So yeah. Let me just see how I can explain a little bit easier. Remember that this is all to the power of 1. So is my base the same? Is it a third? Oopsie, sorry. Is it a third? Yes. Then we drop it like it's hot. And we say thus x minus 1 is equal to 1. Thus x is equal to, add 1 on each side, gives you 2. Let's just test it. Does a third to the power of 2 minus 1 gives you 1? Is that the same as 1 over 3 to the power of 1? Yes, it is. So x is 2 is correct. Okay, then just quickly, Shame, I know it is a long video. Let's just look at the word sums that you could get as well. And I want you to think of making the smaller number, making the one that we don't know is always x. Okay, so they say to you 3 times a certain number. Now, times means multiply. 3 times a certain number increased by 4. Increased means plus is equal to 16. Okay, so can you see that that's my equation? 3 times a certain number increased by 4 is equal to 16. Find the number. So then you're just going to solve for x as normal. Subtract 4 on both sides. Thus, x is equal to 4. You divide by 3 on each side. 16 minus 4 is 12, and 3x is 12 as x is 4. Okay, let's look at number B. Twice a certain number, so twice a certain number means 2x, is subtracted from 13. So if I say to you, leave from Cape Town to Pretoria, where do you start? In Cape Town. Okay, so Cape Town goes first. So if it's from 13, 13 goes first. And because it's subtracted, it's a minus. The result then gives you 5. Find the number. So see if that makes sense. Twice a certain number, which means 2x, is subtracted from 13, which means 13 minus 2x. the result is 5. So if you subtract it, you get the result as 5. Find that number. So 13 minus 2x is equal to 5. Yeah, if you take the positive 13 over, which means you are subtracting with 13 on each side, 5 minus 13 gives you negative 8. And then divide by negative 2 on each side. Oopsie. Divide by negative 2. This cancels out. And x is equal to 4. Okay, so let's just think. Twice a certain number is subtracted from 13. 13 minus twice a certain number, which is 8. The result gives me 5. That's correct. So you can always go and insert that number that you found out again into your word sum and see if it makes sense. Okay. If the sum of a certain number and 3, so the sum of a certain number x plus 3 is multiplied by 4. So if the sum of a certain number and 3 is multiplied by 4, then the answer is the same as multiplying that number by x. Okay, so if a sum of a certain number, the sum of a certain number and 3 is multiplied by 4, then the answer is the same as multiplying that same number that we don't know, by 7. Okay, does it make sense? Hope so. So then we're going to distribute 4x plus 12 is equal to 7x. 7x minus 4x leaves the 12 on that side. 7x minus 4x is 3x divided by 3 on each side. Thus, x is 4. Okay. And then one that teachers love to ask, the sum of 3 consecutive natural numbers is 75. Determine the numbers. The sum of 3 consecutive natural numbers. So let's just say if we had to choose 3 consecutive numbers, what would it be? 5 plus 6 plus 7. Okay, I'm just taking an example. We don't know what these numbers are. So if I take, and we have to represent that first number with x. How would we, the sum of 3 consecutive numbers, how would we represent the 6 if x is 5? Can you see that 6 would be x plus 1, 5 plus 1, which gives you 6. So plus x plus 1. And how would we represent 7 in terms of x? X plus 2. So plus x plus 2. So 5, let's just say x was represented as 5, then it would be 5 plus 1. And plus 5 plus 2. So 3 consecutive numbers you always represent as x plus 1 plus x plus 2. And they tell you that it's equal to 75. Okay, so now we're going to add all the x's. Luckily, if I distribute the positive, it stays positive. So it doesn't really affect my sign. So it's x plus 1 plus x plus 2 gives you 75. And so x plus x is 3x. 1 plus 2 is plus 3 is equal to 75. Subtract 3 on both sides. 75 minus 3 is 72. And then you divide by 3 on each side and you get x is equal to 24. Okay, but I want you to always go and test your answers. So what if I've got 24 plus 25 plus 26? Does that give me 3 consecutive numbers? Yes, the sum of them is the addition of it, and it should give me 75. So it's 9 plus 6 is sorry, my kids are laughing so loudly downstairs. I hope you can't hear them. 6 plus 4 is 10, so it's a 5, 15, 2, 4, 6, 75. Okay, so always go and test whether it does give you what you got. Okay, so just always remember 3 consecutive numbers, x plus 1 plus x plus 2. All right, and that is it. It was a long video, but I'm so proud of you for sticking it out and for learning and enriching your minds and making sure that you've got grade 8 algebra under control. I wish you all the best. Please drop me a message, say hi. I'm always on, not always on my phone, but I always try and make sure that I reply to everyone. And yeah, if you need help, please reach out, and I hope you have a wonderful day further. Thanks, grade 8s. Bye.